In this video, I'm going to talk to you about efficiency. I'm assuming that you already know that energy is measured in joules, and the power, which is the amount of energy per second, is measured in watts, where a watt is a joule per second. And I'm hoping that you've seen the following formula before. It's the formula for efficiency. So the efficiency, which is represented by the Greek letter eta, is equal to useful power output divided by total power input, or the useful energy output over the total energy input. That's the basis of how we define efficiency in physics. However, in real life, there's often a lot more to consider. Let's suppose that we were going to compare three light bulbs, an incandescent, a compact fluorescent, and an LED light globe. Let's suppose we were going to install one of these light bulbs in our house, and we're looking to see what's going to be the most efficient over the next 50 years. And we estimate that we would use the light bulb for a total of 50,000 hours over this time. We would probably care about the cost of the bulb, the cost of the electricity to power the bulb, and how long it would last. And if we were environmentally friendly, we might also be interested in how much CO2 each option would emit, and what are the waste materials when each bulb is discarded or recycled. So let's start by looking at the upfront cost of the bulbs. If we went to a supermarket and looked at the bulbs, the incandescent would probably seem the cheapest, as it's only 50 cents. However, if we try to take into account how many light bulbs we need for 50,000 hours, and we take into account how long each light bulb lasts, then we're going to get a different answer. So let's have a look at the incandescent bulbs. Each one lasts for 1,000 hours. Now, if we're going to be using 50,000 hours worth, that means we're actually going to need 50 light bulbs. So the upfront cost for the incandescent bulb would be 50 times 50 cents, which equals $25. So the upfront cost would be $25 for our incandescent bulb. For our fluorescent bulb, the lifetime's 10,000 hours, so that means that if we want to run it for 50,000 hours, we're going to need 5 bulbs. So 5 times $3.50 is equal to $17.50. So the upfront cost of the compact fluorescent bulbs will be $17.50. And then for our LED, it lasts 25,000 hours. So we're only going to need 2 of them. And the upfront cost is $6. So it's going to be $12 upfront cost. But then we should also take into account the cost of the electricity that it would take to power the bulbs. So if we assume that the price of electricity will not change significantly, which is a huge assumption over the time span that we're considering, 50 years, but if we go with it, then in Australia at the moment you can buy electricity at a cost of about $0.2 or 20 cents per kilowatt hour. Now the question is, what's a kilowatt hour? A kilowatt hour is the amount of electricity that would be used by a 1 kilowatt device if you ran it for 1 hour. And it so happens it's equal to 3,600,000 joules. And it's a very convenient unit that's mainly used on electricity bills, and it's also very convenient for us when we're considering how much electricity these light bulbs are going to use here. This means we need to figure out the energy consumption in kilowatt hours. To calculate this, we need to multiply 50,000 hours of time by the power of each light bulb, which is the energy per time. But first, we need to convert the power of the bulbs from watts to kilowatts. So let's do the incandescent bulb. The energy used will be equal to the power multiplied by the time. And in this case, it is a 60 watt bulb. It's going to use 60 watts of power. And converting to kilowatts, we divide by 1,000. So that's 0.06 kilowatts. And we're going to multiply that by our 50,000 hours. That's going to use up 3,000 kilowatt hours. And the cost is going to be 20 cents multiplied by the number of kilowatt hours, which in this case is 600. So our energy consumption is 3,000 kilowatt hours for the incandescent bulb, and the cost to run the bulb is $600. Okay, for the fluorescent bulb, once again we're going to do that our energy is equal to our power multiplied by our time. And in this case, when we do our conversion, the power is 0.014 kilowatts. Once again, multiplied by 50,000 hours equals 700 kilowatt hours. And when we multiply that by 20 cents per kilowatt hour, we get $140. If we do the same thing for our LED bulb, then we're getting 425 kilowatt hours, which is the equivalent of $85 of electricity. So the total cost for each option is very different to what we would have assumed when we first looked at the prices on the supermarket shelf. Now, if we want to evaluate this even more fully, we could consider the materials used, how they would be discarded, and the CO2 that would be released from each bulb. To find the CO2 released, we could use the number of kilowatt hours of energy used by each one. So in Australia, most of our electricity comes from coal, and approximately 0.646 kilograms or 646 grams of carbon dioxide is produced for every kilowatt hour that we use. So if we want to find the total CO2 that was emitted, we could just multiply this number by the number of kilowatt hours. So for our incandescent bulb, that would be 3,000 times 0.646, which equals 1938 kilograms of carbon dioxide. For our fluorescent bulb, the amount of CO2 would be equal to 0.646 times kilograms per kilowatt hour times 700 kilowatt hours, which gives us 425 kilograms. And for our LED, the CO2 is going to be equal to 275 kilograms. So hopefully from watching this video, first of all, you know the formula for efficiency, but also you're hopefully now more familiar with kilowatt hours, power, watts, kilowatts, and joules, and you're able to consider some of the other factors that people are interested in when they're considering the efficiency of a product like a light bulb.